Hello and welcome to grade 11 college math. We're in unit 4 of trigonometry, and we'll be doing lesson 4 on the cosine law in acute triangles. So we covered what to do with right angle triangles, and we would use our trigonometric ratios such as sine, cosine, and tangent. And then we talked about whether we could use sine law when we have certain combinations. We have one combination but missing the other combination of sides and angles. We can use sine law. Well, we find one more scenario where both of those don't fit, and we can use something called the cosine law. So again, if you are coming from the grade 10 academic, you took up cosine law last year, and this will be a good review. If you are coming from the 2P, this is a new concept, so you're going to have to take some time to grasp it. The good thing is we rely on formulas, and our scientific calculators can be our best friends in all these scenarios. So here we go with the cosine law of acute triangles. Remember, acute means that none of the angles are 90 degrees. So the question comes, can we use primary trig ratios or the sine law to solve either one of these triangles? Explain. Well, here we have neither one of these are right angle triangles. We don't see a little square in any of the corners, and so we must say, well, no, we can't use trigonometric ratios because they're not right angles. And in another case, well, let's check out sine law. What would we need for sine law? Well, we would need a pairing. So let's say, let's take A and angle A. Well, we're missing the angle on this of that pairing. We're missing it. We're missing the angle for the pairing of B and the pairing of C. So we don't have a pairing. On this side, we have the angle, but we don't have the side. So we're missing a pairing here. In all cases, we're missing pairings. So in these cases, we have not enough information is given for sine law. For examples, we don't have any pairs of angle and side. So in primary trig ratios, we used SOHCAHTOA, and the primary ratios SOHCAHTOA are only used to solve right angle triangles. Sine law can only be used to solve triangles if you know two angle measures and any side measure, right? You'd have the pairing of one side and one of the angles and then another angle. Or we would need one angle and two side measures. Provided one of these sides is opposite the angle. Okay, so long story short, it's got to be, you have to have a full pairing and an incomplete pairing in order to do sine law. So we do have a solution to that. If we don't have those scenarios, we have something called the cosine law. The cosine law is an adaptation of Pythagorean theorem to adapt for an angle that is not 90 degrees. And it comes in these forms, and maybe if we had more time, we would show how to derive these equations. But here is the first example if we're looking for side A. The first part looks a lot like Pythagorean theorem. And then we say minus 2b cos A. Notice the pattern here. You're at the left and the right, at the beginning and the end, you're going to start with A. First side A, and at the end, angle A. In the middle, you're going to deal with the other two sides, b squared plus c squared. And then you're going to see it again here, minus 2 times bc. So this pattern is going to repeat. So look what we do when we adapt it for side B. Well, the b is replaced by a squared. The c squared is still there. So now with the combo of the two other sides, minus 2. Now instead of bc, it's going to be ac. And then cos b. Finally, what if it was c squared? Well, we would have a squared plus b squared minus 2 times ab. And then cos large C. Now, we can modify these also to isolate if we look for an angle. Now, these are looking for sides, okay, to solve for sides. Now we'll look at the modified versions to solve for angles. So let's say we were looking for angle A. Angle A would be b squared plus c squared minus a squared all over 2bc. All right, we keep going. If it was angle B we're looking for, we would have a squared plus c squared minus b squared all over 2ac. So again, look at the combination. The a here, or the b here, is the last letter over this way, minus the b. And the 2 times the ac is the two letters that are not the one you're looking for. Well, those will be given information too. So you'll have all the missing information you need to fill in your formula when you're looking for these ones. Okay, so choose which one you want. It is possible to use just the cosine law as it normally is up here at the top one. And you can always alter and use your inverse operations to solve for a missing variable. But if you want, you can use the modified one, and sometimes it will save you a step or two. So the cosine law can be used to solve triangles when given information includes. You're either given here's the best way to remember it, 3 side measures And we say side, side, side. Okay, let's say you had let me write that in. So okay, SSS. So in that example, we're given side, side, side. Or the other one is you have two sides two side measures and the contained angle. Now, contained angle, okay, is the angle between the two sides you know. And we call that side angle side. So SAS. And in that case, we would have something like this. We would know this side, this angle, and this side. So that's the way I want you to try to remember this. When you're given a scenario where your trying trig ratios doesn't work, it's a right angle triangle, so it's not sort of the non-right angle triangles, trigonomic ratios aren't going to work. Then your next step is to think, oh, I'm probably going to have to do sine law. Then you find out you don't have enough of the pairings. If you find out you don't have enough pairings, then you're going to see, oh, okay, the only way that is either I know all three sides, or I know the side, the angle between, and the side. Then you're going to go, oh, that's when I use cosine law. So let's go through some examples. All right. Well, here we have side and an angle and a side. So we have SAS. Okay, so we are going to use cosine law. And we have to decide, we're looking for a side, okay? So you will take something like a squared equals b squared plus c squared minus 2bc cos A. Okay, then you're going to alter it to y squared, because we're looking for side y. And look at the other two sides. Your sides are going to be called y, x, and z. So now it's the two other ones. So x squared plus z squared minus 2. Make sure it looks like a 2. And then x, because sometimes z can look like a 2, cosine y. Okay, so if we take this, now we can all go up and start our solution. So we can have y squared equals, well, what's x squared? X squared is 11 squared plus, you're going to run out of room here too, so just be careful. Z was 8 squared minus 2 times 11 times 8, so those very same numbers, cosine, and the contained angle was 36. All right, that's quite the doozy here. So what do we have now? I'll show you how we can punch this in, but let's go step by step and show the traditional method of doing things. If I go 2 times 11 times 8, let's do this. So 2 times 11 times 8 is 176. So this part of it at least is 176. Cos 36. And what I want to avoid is actually doing this part to get a decimal, because then I'm going to have to round the decimal. If I have to round the decimal, then I'm going to probably round it too early and I'm going to be less accurate. So what I want to do is do this all in one shot. I can go a little further. This will be 185 minus 176. This is probably the last step we're going to do before we square root it. So now I'm going to square root both sides. And this is probably where we take it from here onto our calculator. Now remember, a square root symbol acts just like a big bracket. So everything underneath the square root symbol is a bracket. So this is how you're going to have to input it though. So we have a square root symbol, but you have to tell the calculator to include everything under that square root symbol. So you're going to have to start a bracket, right? And inside that bracket, you can put everything you want. So 185 minus 176 cos 36. And that gives us the cosine law. And here you go. Now you have a nice answer. So I liked what we did there. Let's repeat it. So what I did was I built my bracket first. First I did the square root. Then I said, okay, everything I need is going to be in this bracket that I make. So once I make that bracket, I got 185 minus 176 cos 36. Now, let's say I did it the wrong way. Now that worked out. So what if I did it just to double check, because we're learning how to use this software. So let's say I just did 185. It might work still, 176. Oh, it kept it. Interesting. That's really interesting. So this program is very smart, okay? So if I did this, it's going to keep it all underneath. That's wonderful. That's really good for you guys. Your handheld calculator is not going to do that. So be very careful when using your normal calculator. Okay, so just to experiment a little bit, and we saw how that works. So now we have 6.5. It wanted to the nearest tenth, which is fine. 6.527 rounds to 6.5, and they were calling it inches. So therefore, side y is 6.5 inches. So I hope that made sense to you. Now again, that was an example where we used SAS, side angle side. Okay, so what's the other scenario? Let's try a side, side, side. Side, side, side. We're calling this side A, this side C, this side B. Okay, so using cosine law, what's our thing going to be here? Well, we should probably come up with a strategy of which one do we want to pick first. And it doesn't really matter, but look what they have indicated here, that we're looking for this angle. So find the measure of the marked angle. So they want to know angle C. So if we're doing that, okay, I'm going to show you two different ways using the cosine law or the modified cosine law. So we're going to set up the first scenario, because you can choose. Do you want to use the cosine law or the modified cosine law? And then you can choose whether one saves you some time or not. So if I am looking for this angle, then I am starting with C squared, and then the two other sides, A and B, minus 2 times the two other sides, and then cos big C. Or I can use the modified. Cosine law. Okay, so what was that again? So we look on the first page and we see it's cos C equals the two others, AB squared minus now C squared, all over 2 times the two other sides. Okay, so we'll show it both, because then you can sort of make a judgment call of which one you like better, if you think one saves you time or not. Okay, so we're going to leave lots of room here. So step 1, C squared equals A squared plus B squared minus 2 times AB cos C. Okay, so we have up to there to work. Okay, so let's fill it in. So C was 14. So you can see I'm going to have a number on the left side, and we're going to have to do some rearrangement at the end, but that's not a big deal. We're used to that. We're used to doing algebra and inverse operations and all that, all those types of functions. Okay, so minus 2, and I got 16 here and 17 here, and cos, that's what we don't know. We don't know this, okay? So this is what we're trying to isolate here. So 14 squared is 196. 16 is 256. Again, you can use your calculator, obviously. 289 minus, now what's this going to be? I do have to try that on the calculator. So 2 times 16 times 17 is 544 cos C. All right. And then, so what we're going to do is, well, I'm going to bring, because this is negative, I don't really want it to be negative. So I'm going to bring this one over here. It's going to change the sign. And then I'm going to bring this guy over here, and it's going to change its sign. So helps me. So this whole chunk here is going to be now 544 cos C. And now it's on the left side. And nothing changed here. I had 256. Oh, my pen's acting out again. 256 plus 289. Now minus, we brought the 196 over. All right, good. So now I have 544 cos C. And then what's this going to be? So 256 minus, no, plus 289 minus 196 gives me 349. All right, and so we need to divide both sides by 544 so that we get cos all by itself. So I'm going to have cos C equals 349. Remember, to turn a ratio into to find out an angle, we need to get in a ratio and then second function. So here we go. So I'm going to have angle C equals cos second function, and this very same number, to close your bracket. And we're running out of room, but here we go. What's that going to be? So, all right. So that's a lot of steps here. Let's try this out. We got cos bracket. I don't think we need to do more brackets. 544 bracket. There we go. So 50, and I want it to the nearest degree. So that 0.9 is going to become 1. 50.1. Yeah. And that was in degrees because we're talking about an angle now. All right, so that's one way to do it, using the cosine law with rearranging. So let's try the second way and see if it will save us some time by using the modified version at the start. So let's try step 2. And we have, starting off, cos C equals a squared plus b squared minus c squared all over 2ab. So cos C equals side A is 16, side B is 17, side C is 14. So this is 16 squared plus 17 squared minus 14 squared all over 2 times 16 and 17. So we have cos. Now we simplify. Well, that's 256. Same numbers as over there. It's the same numbers as we had. So, and we will get the same answer. We just want to see if there's an advantage to doing one over the other. 196. 2 times, what was that? 2 times was 544. So a lot of the same numbers here. Okay, so again, look what we're going to have on this side. We're going to have, when I get, oh, right, it's here. It's still right here. See? If I get 256 plus 289 minus 196, I still get 389 on top. 349, sorry. So I guess in 1, 2, 3, 4, we got to, in 4 steps, we got to the same place as 1, 2, 3, 4, 5, 6. So yeah, you're saving 2 steps if this is something that you think you could use. So angle C is going to look the same on this side as it does on the left side. 349 minus 544. And we have angle C will be the same because we will do the exact same thing as here. 50.1 degrees. Okay, so in a way, yeah, the modified one could definitely save you time. Or you can say, I'm just going to learn one equation and then I'm going to use that in both ways. All right, let's go like we did in the previous one with sine law. Let's take a triangle that we start from scratch and we solve the whole thing. Okay, so we're going to solve ABC given that we have this information. We know A, we know B, and we know C. So this is going to be a side, side, side. So I always like to start with a drawing of what my triangle might look like. I start off with A, usually go clockwise, B and C. And then, so this is A, or A would be, now they told us it's 9. Our B is 7. Our C is 8. All right, it does not ask any particular angle to start with, okay? But we have to find all angles. So find all angle measurements. All right, so we need plenty of space here. So what can we do? The first thing we're going to do is rely on cosine law because it is a side, side, side. So we're dealing with side, side, side. So step 1. Cos, let's start with A, simply because of, I'm thinking alphabetical. All right, and since we know we need an angle, I'm going to use that same modified one right here. So I have the angle already ready to isolate. So cos A equals, so B is 7 squared. C is 8 squared. A is 9 squared. 2 times 7 times 8. What do we have now? Cos A. Well, let's use our calculator over here. 7 plus 8 squared minus 9 squared. We get 32. Okay. Well, 2 times 7 times 8 is 112. So change this into an angle, and we have cos -1, 32 over 112 equals angle. What is our angle going to be? So let's try that out. Second function cos, 32 divided by 112. And, use your brackets properly. We have, it didn't say, but we've been nearing to one decimal place. So 73. 39 is going to be 0.4 then. And this is an angle, so we're looking at degrees. So there, now we know C. We know 73.4. Okay, so step 2 of our wonderful solution here. Well, I'm going to give you some advice. We could do cosine law again, but now we actually have a pairing. We have a C pairing and 2 unknown pairings. So really, which one do you want to do next? We could do, because we know pairings, we can use sine law. And so the pairing, let's say I know A now. Now I need to know sine B, let's say. And of course, I'm given side B. And now, from my first step, I was, now I just noticed something really strange. I changed from figuring out sine A to sine C over here. That doesn't make any sense at all. Why did I do that? So angle A, I should fix that. And my pen doesn't want to work. Angle A. And of course, here was angle A. Not sure. I was thinking that last question we did maybe. So we now know the combination of sine A and side A. Okay, so sine B is what we're looking for. So it's going to remain unknown. And B is given to us as 7. Sine A, now we know, is 73.4. And side A was always 9. We are going to cross multiply our 7 up. So sine B is 7 sine 73.4 over 9. Okay, so then we have angle B is second function sine of all of that. So finally, we can punch all this into using the calculator. Just make sure you're using all your brackets properly. So we want to have a big bracket. Back inside that bracket, make a small bracket of 7 sine 73.4. Close that bracket. We want to divide. Oh, I didn't really like what I did there. So, right, close that bracket, divide. There we go, that's better. 9. Okay, 48.2, if we round that, 48.2 degrees. Oh, come on. Doesn't look very nice. All right, well, we have two angles and we don't know the third. What's the way to figure that out? I think we all know it's not that complicated. We just have to do the sum of angles now. Sum of angles. So 3 so angle angle C is going to equal 180. Really doesn't like doing eighths. 180. And pardon me here, we're running out of space. So I'm writing it a little bit, breaking the rules here. But basically we're going to have angle C is going to equal, let's try that out, 180 minus 73.4 minus 48.2, and we have 58.4 degrees. Okay? And you can have a therefore statement at the end. We don't have much room for it right here, but let's say angle A. Angle A was 73.4. Angle B is 48.2. Angle C is 58.4. And there we go. So you've seen the simplest to the hardest of all these examples. And the best way to get accustomed to using the cosine law is practice, practice, practice with your homework questions. Okay, thanks for following along, and we'll see you in the next lesson.